This is a screencast on the first law of thermodynamics and change of phase. A beaker has a mixture of ice and water at 0 degrees Celsius. 600 calories of heat is added. 400 joules of work is done by stirring. What is the change in internal energy of the mixture and how much ice is melted? The amount of heat added is 600 calories, so that's our Q. And the heat is added, which means that that value is positive. The amount of work done is 400 joules. That's work done by the surroundings on the system, so that work done is negative. We would like to apply the first law of thermodynamics, which has us subtract Q and W, so we need both of those numbers in the same units. So we can look up the conversion factor to go from joules to calories, and we'll find that 1 calorie is 4.19 joules. When we work that out, we'll get approximately negative 96 calories. Now we can apply the first law of thermodynamics to find the change in internal energy. First law of thermodynamics says that the change in internal energy, delta U, is Q minus W. In our problem, our Q is 600 calories, and then we have to subtract our work done, and that work done is a negative 96 calories. When we subtract that negative, we'll get a total of 696 calories. So there's our first answer. The change in internal energy is a positive 696 calories. That means the energy has increased by that amount. Now, since the internal energy has increased by 696 calories, that energy acted to melt the ice. So our change in internal energy will be the mass of the ice that's melted times the heat of fusion. Now earlier we said that Q equals MLF, and that was when only heat was added to something. Now we're getting an internal energy change from both heat being added and work being done, so we have to use the change in internal energy as MLF. We're looking for the ice that's melted, so we divide both sides by LF to solve for mass. We get the mass is the change in internal energy divided by LF. The change in internal energy was 696 calories. We can look up the heat of fusion of water and find that that's 80 calories per gram. When you divide that, you get approximately 8.7. And when you simplify the units, you get grams. So 8.7 grams of ice was melted.